The diagram shows two particles P and Q of masses 0.2 kilograms and 0.3 kilograms respectively, which move on a horizontal surface in the same direction along a straight line. A stationary particle R of mass 1.5 kilograms also lies on this line. P and Q collide and coalesce to form the combined particle C. Immediately before this collision, P has velocity 4 meters per second and Q has velocity 2.5 meters per second. Calculate the velocity of C immediately after this collision. At time t after this collision, the velocity v of C is given by this formula here, with t between these values. C strikes R when t is 0.3. State the value of v0. Calculate the distance C moves before it strikes R. Immediately after C strikes R, the particles have equal speeds but move in opposite directions. Find the speed of C immediately after it strikes R. Okay, it's a long question this, so let's have a go at it and see how we get on. We'll just go through it step by step. So here's all the information here that we've summarized from the beginning of the question. Calculate the velocity of C after the collision. Well, we've got speeds of 4 and 2.5 masses, and we've got a combined mass then will be 0.5 kilograms when they coalesce, which is just here really in reality, because they've just hit here and it collides to one solid mass of the total mass 0.5. So apply the conservation of momentum then. So part 1. So I'm just going to write down the equations, I think. Using the conservation of linear momentum, I'll just summarize it. CLM, conservation of linear momentum, gives, in the horizontal direction going forwards, 4 kilograms, no, the speed is 4, times 0.2 kilograms, is the momentum of the first, plus the 2.5 times 0.3, 2.5 was the kilograms, speed, times 0.3 was the mass, let's just double check that, 2.5 times 0.3 is equal to 0.5 times v, and the v would be v0 because that's the initial speed of C. Okay, so that tells us 0.8, this is 0.6, 0.75, tap it in the calculator if you need to, because it's 325 to 75, so it's 0.75 equals 0.5 v0. So that tells us then that v0 is equal to 1.55, 1.55 over the 0.5. So just double this is 3.1 meters per second. So there's the initial speed of C. So v0 is equal to 3.1 meters per second going forwards. Okay, now we've got this velocity here. So we've stated the value of, calculate the velocity of C after collision, state the value of v0. So A here, v0 is the velocity after collision is 3.1 meters per second. Part B then. Calculate the distance C moves before striking R. Well, we know what the velocity is. V is equal to this. So the velocity, this is B, is equal to 3.1 minus 3t squared at any given time. Okay, so that's the velocity. Now, it goes from, when t goes from 0 to 0.3. So the velocity time graph then, the distance will be the area under the curve, is equal to area, which equals the area between 0 and 0.3 of the 3.1 minus 3t squared dt, that's the area under the curve, which equals 3.1t minus t cubed over 3, the 3's will cancel, we'll just have t cubed, between 0 and 0.3. That's equal to, then put 0.3 in here. 3 of these is 9.3, so that's 0.93. Tap that in the calculator if you need to. Minus 0.3 cubed, which is 0.3 cubed, and I'll put that in the calculator now. Minus the 0 values which aren't included, which are 0. So it was 3.1 times 0.3. Let's just type it out long-windedly. Minus 0.3 power 3 cubed, which equals 0.903 meters. That's the distance moved. So that's part B then. Calculate the distance C moves before striking R. Find the acceleration of C before striking R. Well, let's just differentiate now. So if we differentiate this, acceleration is equal to dv dt, rate of change of velocity with respect to time. Differentiate this, is 2 comes down, minus 6t, and that equals minus 6 times 0.3 equals minus 1.8 ms minus 2 when t is equal to 0.3, which is the moment of impact in the picture. T was equal to 0.3 here when it hits R. So there's the acceleration. After C strikes R, each have equal speeds but opposite directions. So let's just draw that picture in now. So here we've got just before, this is C, this is R, this is 0.5 in kilograms. R is weight, I've just got to have another look, 1.5 kilograms, 1.5. This is stationary. This is moving with a velocity v. Here v is equal to 3.1 minus 3 times 0.3 squared. Which, did we work that out before? Let's just tap it in the calculator, just in case. 3.1 minus 3 times 0.3 squared, wasn't it? 2.83. 2.83. So that's the way it's moving there. After the collision, we're told that they're moving with equal but opposite speeds. So this one must be moving away this direction with speed v. This one moves with speed v in that direction. So let's just go back to the question. Each have equal speeds but opposing directions. Find the speed of C after hitting R. Okay, part 3 then. Part 3. Find the speed of C after hitting R. So conservation of linear momentum then gives, in the forwards direction, 0.5 times this, plus 0 is equal to this mass is 1.5, 1.5 v, and this is 0.5 minus 0.5 v. So that tells us what v is, which is 0.5 times 2.83. 0.5 times 2.83, 1.415 meters per second, and that's the speed of v. So answer is equal to 1.415. That's the speed of the particle in question. If we look back up, find the speed of c after hitting R. The speed of c will be this, meters per second.